Guys, today we're covering a direct, inverse, or neither, where you can determine which one it is in all different forms. So we're going to start off working some examples from 1 through 9, and let's write a little note over here off to the side about how we kind of do this. So this will be for numbers 1 through 9. We solve for y to see what equation looks like. Y equals kx or y equals k over x. All right, so let's look at number 3. If I solve to get y by itself first, I have to multiply both sides by x in order to get the y by itself. These x's cancel, and we end up with y equals 4x. This looks like y equals kx, which is direct variation. Next example. Looking at number 5. Again, we have to solve for y. So I'm going to move the x first by subtracting x from both sides. We end up with a negative 3y equals negative x plus 15. Divide by negative 3 to everything. And we end up with y equals 1/3 x minus 5. Now, this does not look like y equals kx or y equals k over x. So therefore, this one is neither, and it's easy to tell right off because it has the plus or minus. It has the y-intercept. Okay, number 7. Again, I've got to solve to get y by itself. It's on the bottom right now. I can't leave it like that. So what I'm going to be doing is I can try and think about this like a proportion, make this x into a fraction, so that then I can multiply diagonally, which that will give me xy equals 16. Now I can get the y by itself. Divide by x on both sides, and we get y equals 16 over x. That looks like y equals k over x, which is the inverse. Moving right along, let's look at the next section. For these, so let's write a little note about what we would do for numbers 10 through 15, and then 20 and 21 as well. Okay, so here, so this is numbers 10 through 15 and 20 and 21. So for this, test all ratios or products. Just a moment. Are you on the phone? Sorry about that little interruption. So we were saying we test all ratios or products. And the ratios are k equals y over x. The products are k equals xy. To see which fits. And it must be the same for all. Oh, Go ahead and move it up to see which fits, and it must be the same for all. In other words, if it's all x times y and they're all the same, then it's inverse. If it's y over x and they're all the same, then it's direct variation. If it doesn't match for either one, then it's neither. Okay, so looking at number 11, or you can pause the video as needed. All right. Whew, that's some big numbers right there. So I'm going to actually start with some to just test out, because you're just testing out. I'm going to do division first. So I'm going to do 217 divided by 31. 217 divided by 31 is 7. I'm doing 140 divided by 20. That equals 7. I'm doing 119 divided by 17. That equals 7. 84 divided by 12. That equals 7. So that means that my K is equal to 7, which means my equation would be y equals 7x, which is in the direct variation form. So that confirms that it's a direct variation situation. Okay, looking at number 13. Okay. Not real sure, but I've already done a direct, so let me try the other one just to see, because that's what you're going to test here. So I'm going to do, because for the K, I'm going to try the products here, x times y. So that means I'm doing 4 times 16. That gives me 64. So I'm doing 12.8 times 5. That gives me 64. 40 times 1.6 is 64. 3.2 times 20 is 64. These are all the same. So therefore, I can say that my K equals 64, which means my equation is y equals 64 over x, because it's inverse, because it's a product that we're doing. We are multiplying them, so therefore it's an inverse. Okay, next page. So I can get the page turned. Okay, moving on to the next section. We're talking about when we're looking at the graph. So let's write our little note over here on the side for 16 through 19. So this is for numbers 16 through 19. We check what graph looks like. Remember, direct variation is it goes through origin as a straight line. Inverse variation, the easiest way is to draw an example. Looks something like this, or the opposite corners. It's got the curves. It's not a straight line. Okay. So let's look at number 16. If I look at the graph right off, oh, it's a straight line. Straight line, and it goes through the origin. So therefore, this is direct variation. If I'm looking at 19, it's not a straight line. It's curved like the inverse variation, but there's not two of them. There's only one. This is technically called a parabola. This is a quadratic. So therefore, this is neither. Let's jump down and let's look at the last example, 21. We're trying to determine, is it direct variation, inverse, or neither? Well, let's test. We got to see both. So we're going to try k equals xy. Then we have k equals x over y. No flip-flop that. Shame on me, Miss Wilson. It's always y over x because it's rise over run. Okay, so we have 3 times 2, which is 6. 6 times 4, which is 24. So this one's an that's not going to work. So now we're going to try this. So we have 2 over 3, 4 over 6. Oh, that simplifies to 2 over 3. We're on a roll. Let's see if this continues. 8 over 12, which is divided by 4. That's 2 over 3. Last one is 12 over 18. Divide by 6, and we get 2 over 3. All of these are the same. So therefore, my k equals 2/3. So it's y equals 2/3 x, and it's a ratio. So therefore, this is direct variation. Again, if you have any questions, please make sure that you ask, and you'll have a great day.